In this lesson, we're going to be looking at graphing transformations of parent functions. And like in our last lesson, we're going to be working with all of the transformations. So those include shifts, reflections, stretches, and shrinks. And then we're going to specifically look at what points we should be labeling in our graph when we do those. Now, in order to understand what points we should label, it's really helpful to look at our parent functions and look at the key point and the nice point in each one. And they're the same in every single one. Notice that right here, y equals x squared goes through 0, 0, but it also goes through 1, 1. And that's what we're going to call our nice point. That's our nice point. And down here, this is my key point, my vertex in this case. Over here in y equals x squared, it also goes through 0, 0, and 1, 1. And so they are also my key point. This is the center of my graph. And then my nice point, because 1 cubed is 1. Same thing here. My key point is my vertex, and we notice that the absolute value of x goes through 1, 1. Square root of x, same thing. My endpoint is 0, 0, and when I plug in 1, I get 1. And last but not least, when I plug in the center of cube root of x is 0, 0. When I plug in 1, I get 1. So every single one of these graphs goes through this point 1, 1. And that is going to be helpful when we do stretches in order to show that we understand what happened to our graph. And so I want you to realize from this that the key point and the next nice point is the same 2 points for each parent function in this unit. In other units, it might not always be that, but in this unit it is. So the first kind of problem we're going to encounter in our homework is ones where we have to graph 3 sets of equations all on the same axis. And so let's just take a look at these equations. The first one, the square root of x, we should simply know that the shape goes like this, and there we go. We've got our first graph, and remember with our key points, this goes through 0, 0, and 1, 1. And let's just kind of mark our 1, 1 because that's going to help us with the other ones. So this one is our blue graph. Let's go and do our green graph next, and we should notice that this has a multiply by 2 on the outside, which means I'm going to have a vertical stretch. That means my key point, instead of going over 1 and up 1, it's going to go over 1 and up 2 because it has a stretch of 2. And so when I draw that graph, it still goes through 0, 0, but there we go. And now I can see what happened to it. Let's look at our third one, which will make our purple graph. This one also has a vertical stretch, but it has a bigger vertical stretch. It's going to stretch, and instead of going up 1 over 1, it's going to go up 3, but notice that we're also going to reflect over the y-axis. So this graph is not going to go off to the right, but to the left, and that key point is over 1 and up 3. And but remember, it's still anchored here. We reflect it over, and there's that third graph. Okay, we should probably label these just to make this clear. So this was 1, 1, over 1, up 1. This one was 1, 2, over 1, up 2, because it was all vertical stretches. And this one was negative 1, 3, negative because we reflected it over the y-axis, and 3 because we stretched it up 3. Now in all of these, my key point here did not change because I did not shift this graph. So my key point does not change unless I shift. Let's look at our next set. So in this next set of graphs, we've got absolute value, and we've got a couple things going on. Let's start with our basic one. And in our first one, we've got 2 things going on. This will be our blue graph. We have a flip over the x-axis, and we're going up 3. So this one, if we go up 3, so there we are at 3, and I have a flip over the x-axis, it's not going to open up, but it's going to open down. And this has no stretches, so I'm just going to go over 1 and down 1 for this other key point. So if I go over 1, that's at 1, and the height is 2. So there's my key point for my first graph. All right, let's use green for the next one. This next one looks exactly the same except for I have a horizontal shrink. That means that when I go over, I'm not actually going to go over a whole one. I'm only going to go over a third of the way. So from this point here, and it's set that same key point here because it's still up 3. I'm still reflecting. But when I mark this, I'm only going to go over a third of the way and down 1. So that point is 1/3 2. And I can draw this graph then like this. So this is a skinnier graph, which makes sense because we shrunk it horizontally. Our third graph, which will make our purple graph, we see we still have that 3 minus, but now we have a horizontal stretch. And so when we stretch it horizontally, instead of going over 1, we're actually going to go over 3. So we're going to go over 1, 2, 3, oops, and then down 1. Let's move that. Oops, I'll try that again. So we go down 1 and over 3. See if I can make space. So 1, 2, about there. And that's going to be the point. So I went over 3 and a height of 2. And there's that one. And this one goes much wider. All right. Let's move on to our next type of problem, which is where we're just given a single equation. We don't have to graph a whole bunch on the same one. And we're going to label our key points on these. But the first thing we're going to do is state the transformation applied to the function. And we're going to do this using order of operations as well. So when we start off, we're going to do what's in the parentheses first. So that means this thing is going to go left 1. That's the first one. Then we're going to multiply by this number on the outside, which is going to be a vertical stretch. And the last thing we're going to do is go down 3. All right, so when we do this one, our key point is only affected by that left 1 and down 3. So let's go left 1 and down 3. So there's our key point at -1, -3. And now my vertical stretch is going to take my next point. Instead of going up 1 and over 1, I'm going to go up 2 and over 1 because I stretched it vertically. Remember, normally I just go up 1 over 1. But when I have a stretch, I look at what happens to the y. I go up 2. And nothing was stretched with the x, so I still go over 1. And that takes me to the point 0, 1. And now that I have those 2 points, I can draw my parabola, which is this graph because it's the parent is y equals x squared. All right, let's try another one. In this one, let's look at what we've got going on. On the inside, our very first transformation is that we have a horizontal stretch. Next thing we see is this negative here, which means we're going to flip over the x-axis. The last thing we're going to do is go up 1. So let's start by getting our key point. Our key point isn't affected by stretches or flips, but it is affected by going up 1. So our key point is right here at 0, 1. Let's just remember, actually we'll draw in the shape in a minute. Now when we do the horizontal stretch, we're stretching it by 3. Because we're multiplying by 1/3, we're actually going to stretch it by 3. Which means instead of going up 1 and over 1, we're going to go up 1 and over 3, but I flip over the x-axis. So instead of up 1 and over 3, I'm actually going to go down 1 and over 1, 2, 3. And here's my key point at 3, 0. And now I need to remember that shape of y equals x cubed. So let's just remember the normal shape looks like this. So this is y equals x cubed. If I flip it over the x-axis, the shape now looks like this. This is y equals -x cubed. That's going to help me to draw this. So now I've got this thing going like this and like that. And that's because we have that horizontal stretch going on. All right, let's try one last one. So in this one, the first thing we have on the inside is this 4, and that 4 is going to be a horizontal shrink. And then on the outside we have a vertical stretch. And let's just label these. The horizontal shrink is going to divide by 4 because we're multiplying by 4. The vertical stretch is going to multiply by 2. And then we can see that we're also going to flip this over the x-axis. Our key point doesn't move anywhere. Notice there's no shifting, so I'm going to be anchored at 0, 0. That won't change. And I'm going to flip over the x-axis. So remember, our normal shape is like this. When I flip over the x-axis, it's going to do this. So this is y equals root x. This is y equals negative root x. Now I just have to get that key point in the right place. So since it's a horizontal shrink, I'm not going to go over 1. I'm actually going to go over a quarter. And instead of going down 1, I'm going to go down 2. So I'm going to end up at this point at a fourth negative 2. And there's what my graph is going to look like. All right, your homework for this next section is assignment number 6. You can find it on your website or just keep it here and write down all of these problems.